Hey everyone, welcome. In this video, we're going to go through how to configure IP SLAs to influence some routed traffic within our topology. Our scenario is we've got two connections up to two different ISPs, one across routers 1's 100 meg link and router 2's 10 meg link. We want to make sure that all traffic within our topology traverses our router 1's 100 meg connection. So in order to do that, we're going to set up some IP SLAs and some trackers in order to attach to our static routes that will then be injected into the routing table. We're also going to influence the traffic in our OSPF topology a little further with adding some metrics to our default originates so that we have a little more of a visual identifier where that traffic's coming from, either from router 1 or from router 2. So let's start taking a look at the configurations. So on router 1, if we show run interface gig03, that's our 100 meg link, and if we show run pipe section IP route, should see our default route there, out gig03, and a show run section router OSPF will show us our OSPF configuration, and there's our default originate. Same thing over on router 2, show run interface gig03, and there's our 10 meg link, show run pipe section IP route, shows us our static route out gig03, show run pipe section router OSPF will show us our OSPF configuration, and we're originating a default route from router 2 as well. So let's go down to router 3 and take a look at the routing table and see where we're getting that default route from. So show IP route 0.0.0.0 shows us that we are getting it from OSPF, administrative distance of 110, metric of 1. That is coming, currently we are going out router 1's interface, or router 1 for our default route. Number 1, because that is the oldest route that we know about. So we learned about this one before we learned about router 2's connection. So if I was to fail over and say disable router 1's interface up here, config T interface gig03, and we shut that interface down. That's going to remove the default route from our table. So if we do show run, do show IP route, you should see we're getting a default route now from router 2. And then if we go up to router 3, back to router 3 and show that route, we can see that it's coming from router 2. If I turn that interface back up with a no shut, and then once that interface comes back up, that static route comes back in right here. We've got a static now instead of an OSPF route. And if we go back down to router 3, we know about 2 routes, but router 2 wins the tie, mainly because it is an older route. So it's going to hold on to that until router 2 goes down and we swing back over to router 1. So that's a scenario that we don't want to happen. We want to have our traffic always fail over to router 2 if router 1 goes down or we lose connectivity out of router 1. And if router 1 comes back up, we want that traffic to swing back over to router 1. So let's go ahead and get started with the configuration on how to do that. So we're going to start with an IP SLA. So IP SLA, give it a number of 10. We're going to use the ICMP echo. And we're going to ping the other side of that connection that we have, out gig03. If we remember from our interface connection here, 10.1.10.2 is our IP interface. So we're going to go 10.1.10.1. And we're going to source that from our interface gig03. We're going to do that every 5 seconds. We're going to drop down and we're going to start scheduling that IPSLA to start pinging that address. So we say IPSLA schedule. We're going to schedule our number 10 SLA. Our start time is going to be now, and our lifetime is forever. So to check and see that that's working, if you do a show IPSLA statistics, so we've had 1 failure and 2 success so far, 3 successes. So it's pinging it now every 5 seconds, and as long as it's pinging it, it knows that that connection across gig03 is up. Okay, so the next thing we need to do is assign a tracking mechanism to that IPSLA. So we'll keep it simple. We're going to set a track ID of 10 for IPSLA 10, and we're going to track its reachability. Okay, that's all we need there. We drop back down. Now we need to add a new static route with the tracking mechanism in place. So we say IP route for the quad 0. Out gig03. Oops. We're going to give it an administrative distance of 25. And the reason we're doing 25 is, let's say we want to implement BGP. We start learning our default route from BGP, external BGP. External BGP administrative distance is 20. So we're going to want to favor the external BGP route over our static route. So we'll go ahead and put 25 in there. And if we happen to configure BGP, BGP will take over. And then we're going to track our number 10. All right. So show run pipe section, actually do show. Section IP route. And you see we've got the 2 routes in there. We need to remove the older route. So we'll say no and drop that. So since we're removing that, we might lose, we may lose 1 of our pings across there and have that policy go up, down. Right there. So we lost 1 ping across that interface when we swapped over, and now we're back up again. So show IP route, we should see our static route still there across gig03. Lastly, we're going to configure the metric on our origination of that default. So we say router OSPF 65100 default information originate. We're going to give it a metric of 10 from router 1. And we're going to write that to memory. All right. Same thing over on router 2. We'll config T. Let's do show run interface gig03. We're going to set the IPSLA. Keep it simple. Same on each side. SLA of 10. ICMP echo. We're going to ping the 10.2.10.1 address. We're going to source that from our interface gig03 every 5 seconds. All right. Exit out of there, and we're going to schedule that to start. So we say IP SLA schedule. We're scheduling our number 10. Our start time is now, and the lifetime is forever. Okay, let's go ahead and make sure that that one is running. So if we show IP SLA statistics again, we see that we've had 2 successes so far since implementing that configuration. And now we have 4 and 5. So we know that that IP SLA is working. Now we're going to go ahead and set up the tracker. So we're going to track 10 IP SLA 10, and we're going to track its reachability. We'll exit out of there again, and then we're going to set that new IP route to 0.0 out gig 03. And on this side, we're going to make sure that this route is not put into the table unless we lose connectivity on router 1. To do that, we're going to make sure that it's above the administrative distance of OSPF, so we'll set it to 111, and we're going to track on 10. Okay, do show run, pipe section, IP route, and we'll get rid of the old route. Drop that out. Lastly, router OSPF 65100, and we're going to set our default information originate metric of 20. Write that to memory. All right, let's show IP route. And we should be getting the default route from our router 1's router 1. We're getting it from OSPF external type 2, and we've got a metric of 10 because we're self-generating that metric with the default originate. Okay, so this is great, but does it work? So we already know if I was to shut down router 1's gig 03 interface, it's going to drop that static route immediately because it has no, it's not reachable. We know that, and it drops that static route. Let's say there's something that happens though across that circuit, right here, that 100 meg circuit. Something goes wrong, we lose reachability. So to simulate that, we're going to go ahead up on ISP1 and shut down its interface to router 1. Interface gig 02, and we're going to shut that down. And let's pop back over to router 1, and we'll watch as that. We should see the tracking mechanism fail. Right there, we went from a reachability of up to down. So that static route should have been removed from our table, and now we're getting the default route from router 2, and we can verify that with a show IP route. And we are getting an OSPF external type 2 with a metric of 20. Let's go back down to router 3 and see where we're getting its route. Should be the same. And again, OSPF external type 2, metric of 20. So we know we're going out router 2. Okay, this is half the scenario. Let's go ahead and bring ISP1's connection back up. No, shut that interface. Well, let's make sure that when we regain connectivity across our connection, that our routing swings back over as well. Again, we just have to wait out that timer for it to try and ping across that link. And we should see it go from down to up. Right there we go. We went from down to up. And now we should have a static route on router 1. And we do. And what does router 3 see? Router 3 now sees the external type 2 coming from router 1, that metric of 10. So everything is working as we want it to. We will use that 100 meg link unless that connection goes down or there's some sort of problem across that circuit where we can't reach the other side. We're going to swing our traffic back over to router 2. If that connectivity comes back up, we're going to swing back over to router 1 and use that 100 meg link over that 10 meg link. So it's very useful to have in a lot of different scenarios, those tracking mechanisms and being able to manipulate your routes within the routing table. So I hope you found this informative. Thanks for watching. Please like and subscribe to be notified of new video content.